Hi, my name is Arda, and this wind-up car was my fourth project while taking TEKX 101, a 3D printing course at SFU. As I enjoyed printing and assembling it, I wanted to show you what 3D printing is, why I chose this car, and the steps I took so even a beginner can bring their own car to life. So for my fourth project, I was tasked with printing something more complex than what I printed in my first project. And as I printed this small elephant for my first project, the new print had to involve more post-processing, require high print accuracy, and still be fun to make to meet that requirement. This wind-up car checked every box. So what is 3D printing? 3D printing, or additive manufacturing, builds objects up layer by layer. A printer squeezes melted plastic filament one layer at a time, adding each layer on top of the previous until the object takes shape. You can think of this process like you're building with Lego bricks. You lay down each brick until the full layer is complete, and then you start building on top of that layer until you are done. So to get started with printing, you need a model, and in my case, I needed the wind-up car. Thingiverse is a website that gives free models designed and created for 3D printing by other individuals. You can search wind-up car in the search bar, and we will find the car you want to print by Brero12. And after downloading the STL files of the gift card version of the model, it's time to use Cura. Cura is a free 3D printing software that prepares models for printing. It lets you adjust settings for both the printer and model, but for this car, you'll only have to look at Cura's recommended print settings. So after inserting the model, we now look at the resolution. Resolution is the layer height or thickness of each printed layer. The smaller the resolution, the more detailed and smooth surface you will have, but at the cost of more print time. I used 0.15mm as it gave me a detailed and accurate print while not costing too much extra printing time. Next is infill. Infill is the internal structure that gets printed inside your object to give it more strength. It allows your model to be sturdy yet light, while also reducing the print time required. For the car model, I went with a solid 100% infill. This is because we want our car parts to be as sturdy as possible for when we need to wind up the car. Supports are printed structures that help parts of your model that have overhangs. Without these supports, your model can collapse during the print. Luckily, the car model doesn't need support, as it doesn't have any overhangs, so we can leave the setting turned off. Adhesion makes your model stick to the build plate of the printer using a brim of plastic so that it doesn't warp or come loose. I didn't use adhesion in my print in order to keep the car's pieces clean and accurate. Instead, I used a glue stick on the build plate of the printer to still have some grip with the model. Once you're done your settings, it's time to slice the model. Slicing is the process of converting your 3D model into thin horizontal layers and generating the corresponding G-code from it, the step-by-step instructions your printer uses to print your model. This includes things like how fast to move, what temperatures to use, etc. Cura also gives the estimated print time and materials used in this step, so keep that in mind. Once I was satisfied with how everything looked, I saved the G-code onto a USB and it's now time to print the model. As I'm a student at SFU, I went to the school's makerspace to print my model. After inserting the USB stick into an Ultimaker 3 and selecting my model, I hit print and watched the printer do its magic. I watched for about 15 minutes for the first few layers to print, as it's during this time where most errors occur when printing. And so, after 7 hours, we now have our printed model. Now that the car is printed, we now have to assemble it. To do this, I used a pair of pliers and a hobby knife to cut out the pieces of the car. Then I used an assembly guide from the model's creator to put the model together. One issue I had was that the back wheels of the car were loose, so I ended up putting silicone on the joints to hold the wheels in place. And with that, the car is done. I learned a lot during this project, and even though I thought I had taken proper steps to ensure accuracy, it still ended up with loose wheels, which was a bummer. But I'm still proud of what I made. If I were to do this again, I would have tried adding a small adhesion brim to the model to help with the accuracy issues. Thank you for watching.